extension of what we did yesterday, and what we did for the last three, which is finding, we should be listening, not talking. We have been finding a function rule, and then we did a specific function rule, which is the direct variation. And today we're going to be doing series and sequences. Well, specifically, actually mostly a sequence is what we're doing. So we're doing a sequence. But basically this is a pattern. So, here. What comes next?
5, 6, 7.
5, 6, 7, and so on. So yeah, that's what we're doing. Now, here's the trick. Again, with a function rule, you need to be able to write two different types of rules for something like this. The first type of rule is called a recursive rule, and it's actually the easiest to find. Recursive? What is that? Recursive writing. Recursive. That means that our pattern is determined. My thing is not cooperating. Our pattern is determined by the previous terms. So, in this case, what I would have is my next term, a sub n, okay, is going to equal the previous term, a sub n minus 1, that's our previous term, plus one more, okay, because we're adding 1 each time. So that's a recursive formula because our term, whatever term number we want, and that's n is our term number, so if I wanted, in this case, a sub 4, okay, I take a look at the third term. That's going to equal the third term plus 1. Well, what's the third term? The third term is 3. So 3 plus 1. So that's 4. So a recursive formula is a formula that's determined by the previous terms. So, generally, when we write these, we need to know two things. We need to know, first of all, the first term, whatever that is, and we need to know our pattern, whatever that is. So let's try this one. All right, what would come next? 18 would come next. What would come next after that? All right, so what's our first term? Well, our first term is this 6. You with me? And how am I getting each next term? Well, I'm adding 3, right? So our recursive formula is going to be a sub n equals our first term, in this case 6, okay? Now I need my pattern. I need to know, actually this is going to be the explicit formula, because that allows me to find any term. So in our explicit formula, I need to know my first term, and then I need to know my pattern. Alright, so what am I doing each time?
Adding by 3.
I'm adding by 3. So 3 is part of this. Now that is only going to give me the second term, right? So I need a little bit more here. Like if I go to this like if I go to this term right here, 12, how many times have I added 3?
2.
Okay, if I started the first term, how many times have I added 3 if I started the first term?
3.
If I want the first term, how many terms have I added 3?
2.
0.
Oh yeah.
Okay, I don't know where you're getting like 2 and 3 from, because if I start right here, have I added a 3 yet?
No.
No, I haven't added a 3 yet. Okay, so I've added 3 0 times. Right here, if I go to 9, how many times have I added 3?
1.
And if I go to here, how many times have I added 3?
2.
So do you see, if I just multiplied right here, now, if I want the third term, how many times have I added 3? Twice. So I'd multiply by what?
2.
So 6 plus 6 is 12, right? Now, I need it to be like any term. What if I wanted this 18? Well, I've added 3 times, and then right here at 18 I've added 3 4 times. So what would I put here?
4.
Now, what term number is this? This is term number what?
4.
Careful. It's not term 4. This is term,
1.
term,
2.
term,
3.
term,
4.
term.
5.
Okay? Now take a look at this pattern here. What term is this?
4.
4. What term is this?
3.
What term is this?
2.
What term is this?
1.
Notice the number of times I've added 3. It's always 1 less than my term number, isn't it?
Yeah.
So inside of here, I could write n minus 1. This is my explicit formula. This gives me any term. So if I wanted a sub 100, well, that's the 100th term. I would do 6 plus 3 times 100 minus 1. What's 100 minus 1?
99.
So it'd be 6 plus 3 times 99. So then we get our calculator.
Ah,
297.
So I'd have 297, and then I'd add 6 more and get 303. Okay? All right, what comes next?
11,
Okay, 11,
13, 15.
and so on and so forth. Okay? Now, if I wanted an explicit formula, that's going to be a sub n equals a sub 1, and then plus my pattern, whatever that is. Well, what's my first term? See, this 1 means the first term. So what's my first term? 5. Now I need to figure out my pattern here. It appears I'm doing what each time?
Adding 2.
I'm adding 2 each time. But if I wanted to say this term, which is what term? This is term 1, term 2, term 3, term 4. 13 is the 5th term, making 15 the 6th term. How many times will I have added 2 when I got to here?
4.
4 times. Why? Because the first term I haven't added anything yet. Add 2, add 2, add 2, add 2. Okay, so if I'm stopping at this term, I've added 2 how many times?
4.
So I do 4, or 2 times 4, right? So what is that? We'll take a look. My term number I want is 5. Okay, so it's times 2, 1 less than that. So this is my explicit formula. That's actually the answer when I'm asked for the explicit formula. I don't have to do anything else. But it's kind of tricky getting it. Now luckily, in the case of repeated adding, whenever we have repeating added or subtracting, they all have this form. A sub n equals a sub 1, sub meaning subscript, plus d, I'll tell you what that is in a minute, times n minus 1. They all have the same setup. This d represents what's called the common difference. That means whatever I'm adding or subtracting is my common difference.
It didn't work, James.
The force doesn't work on me. I don't
Force
have
is
like
not
a,
with you.
I'm trying to get my drink here and it's way over there and man, I could use the force.
Just use slave Coleman.
It's like cobalt slave.
Alright, so when we have anything, whenever we have repeated adding or subtracting, we have what's called an arithmetic sequence. It means repeated adding. Did you have a question?
Oh yeah.
What was it?
Arithmetic sequence.
Looks like arithmetic.
Find the next three terms for both of these. And then I want you to tell me, is it arithmetic? So you can write yes or no. Remember, arithmetic is repeated addition or subtraction.
Well,
This. Maybe 6. This.
Are we finding the orthocenter?
Yes.
Okay, so let's say I choose this point. That means I'm going to connect it to this line. So this line looks like down one, right one. Okay, so that means I need to go up one, right one. Okay, so if I connect those, meets right here.
That's it.
Yeah. Okay. All right, what'd you get for the first three blanks of this one?
14, 17, 20.
Is that arithmetic?
Yes.
Yes. So that means we can write our arithmetic formula. A sub n equals, now it's my first term. What's my first term?
2.
So it's going to be 2 plus, what's my common difference? How much was I adding each time?
3.
And this is my arithmetic formula.
I have a question.
Yes.
How do you know if it's error? You said repeated adding and stuff, but aren't they all?
Well, let's take a look at this one. Not all of them will be that way. Let's take a look at this one. You might think, well, how do I go from 2 to 4? Plus 2. All right. If I add 2 to 4, do I get 8?
Oh,
No.
No. Okay. What's another way I could go from 2 to 4?
multiply by 2?
Times 2. And then 4 times 2 is 8, and 8 times 2 is 16, and 16 times 2 is 32, and 32 times 2 is 64, and 64 times 2 is 128.
you're like,
So this one is not arithmetic. Now I can write a formula for it, but we won't focus on that for today. We'll only write them if we have an arithmetic sequence. Let's try another one.
Wait, what was the last one?
128. Just tell me what comes next. And then, is it arithmetic? And if so, what's the formula? How do I go from negative 7 to negative 3? Possibly. Maybe add 4. How do I go from negative 3 to 1? Maybe add 4.
That's another.
1?
Okay. And then how do I go from 1 to 5? So maybe...
I was overthinking that.
So 9's next. Is this arithmetic?
No.
Was this...
Yes, I'm sorry.
It's arithmetic if I repeatedly add. Did I repeatedly add the same
Yes.
thing? Alright, so what's my common difference?
2, 4.
Yes. It's 4. So then I can write my formula. A sub n equals negative 7, because that's where I start, plus 4, that's my common difference, times n minus 1. That's my formula. So with this formula, let's find let's find the 80th term. Because you're not going to want to count 80 of these out, are you?
No.
That's the whole point of getting this formula. So to get this, all I'm going to have to do is replace n with what number do you think?
Is 80.
80, because I want the 80th term. And then I just simplify this down. You getting this, Tracy?
3.
Yeah, I can see. About time for a notebook check in here, I'm thinking.
No.
You're lucky that the other volleyball team was gone.
Right.
Well, your time's coming, Tracy. Just ask
I'm
geometry.
not. We should just.
Give me an 85 on it.
It gave me an 80 because I didn't copy down every
I
single
take like
word.
great notes.
They just
Like my
wanna
notes
do
are
it
for me, not for
Yeah,
somebody else.
not for like nowhere. We need like a lot of examples. I'm not being mean. I'm just saying they need a lot more examples. It's a damn.
Who's dang?
All right, let's come to the next one. Coleman almost died right there.
4 out.
Minus 4.
Okay, so it's minus 4 each time, so what's right here? A 1, right? So what's my common difference?
1. Minus 4.
Yes.
Negative 4.
Yep. Common difference is negative 4. Alright, so let's write our formula. A sub n equals, now we do our first term, which is 17. Now instead of plus something, it's going to be minus something because it's repeated subtraction. And then in parentheses, n minus 1.
Andrew, step the right direction.
What?
Did you torture them, Cam?
Yes.
How bad?
Bad.
Get the right direction on every single problem we did.
And like the pages he would assign at least 2. Did
y'all make 'em mad?
Yeah, real off the wall problems
Well,
that
we just wouldn't
had
do it.
directions like this long.
And it takes like, ended up like taking like 10
Yes.
pages.
And if you didn't do it, you got like,
Yeah, 10
it might
points
be
off.
basically, yeah. You drop your grade basically.
Let that be a warning to you for geometry next year. Follow directions and you won't have to be like them.
Is that the only reason why you made them do it?
Yeah, because they weren't following directions. That'll learn them.
Teachers.
Learn
What
them.
kind of salary did you get?
Alright, so get these 3 questions written down, and it says find the 2nd, 5th, and 9th term.
Okay, I'm stupid. What's the slope for downward left one? Downward left.
What slope are you doing?
Left to right.
Yeah, you go left to right, so it would be positive 1 and 1.
Okay.
Well, wasn't positive 1 1 just be 1?
Yeah. Let's put that negative for 6.
Wait a minute.
So to find the second term, we replace n with 2. I get 5.
Yeah.
Any questions?
Oh!
Oh, we got.
Bless you.
Bless you.
A sub 5. Okay, that means the 5th term. Use the same formula on given.
Do it 3 times.
So I get 14. And what do we get for the 9th term?
2.
Hang on.
Early good number.
Okay, so try the remaining 2.
I didn't realize we had to do 3 of them.
Oh, yeah, so for each.
How did it get negative 2 zeros?
Okay, which one are you doing? This one. Okay, so you connected this.
Yes,
Okay.
but it says here it's negative 2 0.
Well, you have to do 2. Just like with in circumcenter, you need to do that's not an altitude.
It's not.
No.
Oh, yeah, it's
It
not.
has to go straight down.
Shut up.
So I would do the altitude of this one, so I'll use this line over here. So that looks like it's going up 3, right 1. So if it's up 3, right 1, I'm going to go down 1,
Right 3. You went left 3.
well, no. I'm going to go down. Okay, so the slope of this line was 3, 1.
Yep.
Okay, the perpendicular line is negative 1/3. So
Yes.
I'm going to go down 1, right 3. Down 1, right 3. Okay, so. Okay, that appears to not meet anywhere, so I need to extend this one, and they meet right there.
You're all within 27?
Yes.
Why are you size so low?
Because he hates y'all.
Hey, bloody y'all.
I know.
For his favorite class.
Wait, is there an easy way to do this, like a formula we can use to find that besides graphing?
No,
There's never an easier way.
graphing it is the. Check your answers with the ones that I had.